Hello students, welcome to Apna Tutor channel. I am your Mehak ma'am, and today we'll be discussing about another topic, that is electric dipole of the chapter electrostats. Okay, so let's start with the topic. Electric dipole is basically it is a system of two charges. So we have a positive charge and we have another charge which is opposite in sign, that is we have a negative charge, and they must be separated by a small distance. Okay, so mm, the conditions must be that we must have equal charges and they should be opposite in sign. So if we have plus 2q and minus q, that will not form an electric dipole. Okay, also if we have plus q, so it will also not form electric dipole. For that we must have equal and opposite charges and they must be separated by small distance. Okay, so these are the conditions, and if we need to define it, we can define it in this way, that it is a configuration of two charges of same magnitude and opposite sign, and they are separated by small distance. That configuration is called the electric dipole, right? So if we have to see the examples, mainly we'll get the examples of the electric dipole from the chemistry. Suppose we have a molecule called HCl. So it has a positive sign contributed by hydrogen and negative by chlorine. So it is a perfect example of electric dipole, right? Now if we need to measure the strength, that how much a dipole is polar, so in order to measure the strength of the dipole, that will be given by another quantity, that is, so in order to measure the strength of the dipole, to measure this, that will be given by electric dipole moment, right? So if magnitude of dipole moment is quite large, we can conclude that the molecule is highly polar in nature, and we can have the understanding of all the properties from that. Okay, so it is very important to measure the strength of the dipole, and this quantity is very important, and we usually denote it with the symbol p vector. Okay, so it is a vector quantity, and dipole moment is a vector quantity, and its magnitude will be, q into distance. So q is the charge or any charge, and distance separated between the two charges. So this will be the magnitude of the dipole moment, and the direction will be from negative to positive. So the direction of the electric dipole moment will be from, for the direction it will be negative to positive, right? So this is magnitude. Now as we know the formula of dipole moment, now we can give its units. SI unit will be charge into distance. So charge, for the charge it will be coulomb, and for the distance it will be meter, right? So if we need to define the dimension of this dipole moment, will, for the charge we'll be writing it as current into time, so it will be a t, and for distance it will be l, so atl. This will be the dimensional formula for the dipole moment. Now let's solve the question. We have a question here. A system has two charges. So we have a charge QA to be 2.5 into 10 raised to power minus 7, and another QB charge of, again now we can see we have the same magnitude but the sign is opposite, and they are some at distance located at, so let it be z-axis, and one is at plus 15 and one is at minus 15. So for minus 15 it is qa, and for plus 15 it is qb. Okay, so it is minus and that one is positive. So they are located, and we have given the picture of this. So we have to write the dipole moment. So this is the sign of dipole moment of the system. So for the dipole moment, for the magnitude, first of all I said that it will be q into a. So we have charge is equal for both, so we can take 2.5 into 10 raised to power minus 7 into a. Now what is a? So a is, this is minus 15 and this is plus 15. So for the total distance between them it will be 15 minus minus 15, so it will be plus 30 centimeters. Okay, so we have to write it in SI units. For SI we'll be dividing it by 100. Okay, centimeter to meter. And on solving I'll get 7.5 into 10 raised to power minus 8, and the units will be coulomb meter. Okay, so this is the magnitude of the dipole moment. Now for the direction, we know it is from negative to positive, so it will be negative to positive, so it will be in this direction, that is in minus k cap. So we'll be writing here, so we'll completely write here. So it will be 7.5 into 10 raised to power minus 8 coulomb meter. This will be the magnitude into minus k direction. So this is the dipole moment of the system, right? Now let's solve another question. Okay, so now we have question number 2. Suppose we have a configuration like this. We have 3 charges placed in such a way. So let it be point A, where plus q charge is placed, and at this point minus 2q is placed, and at C q charge is placed, and they are at distance of A. Okay, so it is a equilateral triangle, and we have to find the dipole moment. So dipole moment of the system, again the same question. So now we know that dipole moment is a vector quantity, right? So we have to solve it vectorially. So now what we'll do is, we'll break this minus 2q into two charges, since we are not able to see here the dipole clearly. So what we'll do, it will be like minus q and minus q. So we will keep two minus q charges, so it will be equivalent to minus 2q charge. So we'll form a dipole in such a way. So from A to B we'll have a dipole, this minus q, this one, and this A. So this will be a dipole form, and this another minus q will be forming dipole with this plus q. Okay, so we have two dipoles over here, A and B. So this will form a first dipole and this will form a second dipole. So our system will be equivalent to this way. Now we'll form, so we'll have one dipole minus 2 plus, so arrow will be in this side, since we know the direction is from negative to positive. So this will be our p1, p1 vector, and this will be my p2 vector. Okay, so this will be the dipole, and we know that all the three sides are equal, so it will be equilateral triangle, and the angle between them is 60. Okay, so this is the 60-degree between two dipoles. So my this triangular configuration changes to this configuration. Now I can easily apply the vector addition formula over here. Okay, so net dipole moment will be, if I have to calculate, so it will be p1 square plus p2 square, and it will be plus 2ab. So p1 p2 cos theta will be cos 60, right? Now if I write the value of P1 will be Q charge into A, and similarly P2 will also be charge into A. Let me call it P1 equal to P2 equal to P. Okay, so P net will be now under root P square plus P square plus 2 P into P will be P square, and cos 60 will be half. So we'll get under root 3P. So this will be our answer, or we can write it as or under root 3Q into A, right? So in this way we'll solve the questions. Now we'll move on to next topic, that is electric field due to dipole. Okay, so we need to find, first of all let's find electric field at the axial point. So we have a configuration in this way. Suppose I have a dipole minus q and plus q separated by some distance, let me call it to be 2a, so that our calculation will be easy. So let it be at point A and let it be at point B, and we have to find the electric field at some distance P, okay, at the x-axis. So it is, the point is at axis, so we say it to be axial point. Okay, so if we measure the electric field at point A due to point negative charge that is placed at A, so at point A that will be, since we know that the electric fields for the negative charges are inwards, so we can write electric field due to A will be towards it, and for the electric field due to B will be outward, that is away from it, that is electric field at B will be towards x-axis, and the center of the dipole is at point A, let it be O point. Okay, so the distance from the center to point B, let it be x. Now we have to find the net electric field at point P. Since we have two electric fields at point P, so the net electric field will be, for now we'll just consider to be the magnitudes, and that net electric field will be for the point A. So for A, the magnitude will be K Q upon, for the A it will be X plus this A distance also, since it will be A and A, so this X plus A for the electric field due to A point, and that will be X plus A the whole square, right? And this direction, for the direction, if we have to see, the direction of the electric field is from P to A, from P to A. So if we have to write the electric field due to B, for B it will be KQ upon, so we have to see the distance this, so the distance will be, whole is x, and we need to subtract x minus A whole square. So this will be the electric field due to B, and the direction will be from P to X. Okay, so this is the direction. Now we can see that since the distance of A is greater than B, so we can say that the electric field magnitude of B is greater than electric field of A, right? Okay, and also the electric fields are acting along the same line, but they are opposite in direction. For that, in the opposite direction we'll write the net electric field. So this is the net electric field including direction, and that will be kq upon x minus a the whole square minus kq upon x plus a the whole square. So it is basically electric field due to b minus a. Okay, so this is the electric field net. Now we need to just solve it, and so taking the LCM and taking q up common, so it will be 1 by x minus a the whole square minus 1 upon x plus a the whole square. Now take the LCM kq, x plus a the whole square minus x minus a the whole square upon x minus a x plus a the whole square, right? We can write it in this way. So we can solve it kq upon x square plus a square plus 2ax. Similarly, we can write it as x square minus a square plus 2ax. Okay, so since we have a negative sign at front, now it will be x square minus a square the whole square, right? Now these will be cancelled and we'll left with kq upon 4ax. This, okay, so now here we have a condition. So the condition is x is very much greater than a. So the distance or the point at which we are measuring the electric field, so that distance is very much greater than, this was the x, right? This one. So this one is x whole. So this is very much greater than a, that is the distance between the dipole. Now we can apply this condition. For that condition we have to eliminate this a, so we can ignore the a and we left with 4ax upon x to the power 4. Now we can write 4kqa upon x cube. Okay, now if I rearrange it, k q into 2a, okay, so into 2 upon x cube. So this will be my again dipole, so it will be 2kp upon x cube. So this will be the electric field due to dipole at the axial position, and the direction will be along the p, since we have seen that the electric field due to the b is greater than a, so its direction will be along the p, which is an important result. Okay, now let's move on to another part. If we have to find it at the equatorial position, so for the equatorial position we have to find the electric field due to the dipole. So again we can have the configuration of minus q plus q charges separated by 2a, and now it can be the point we can have is here. Okay, so the p point is at the equatorial position. Now we have to find the electric field at this point, so we can join these 2 points. Okay, in this way, so the electric field due to the minus q charge will be in this direction towards the minus q, and for the plus q it will be away from the means outward direction, so it will be the electric field due to plus q charge, and let me call it to be a and b, and this distance, whole distance, is to be y, and this is some theta angle. Okay, so this is electric field due to b, and this is electric field due to a. So, and now we have this angle also, since these are alternating angles, so this is also theta. Now we have a configuration in this way. We have this configuration. Okay, so this is the theta angle, and this is electric field due to A, and this is B, right? Now my this will be E A cos theta, and this will be, if I make the components, E A sin theta. Okay, and again this will be E B sin theta, and this direction will be EB cos theta. So this is the components which we have splitted. Okay, now since we have same magnitude, same distance, so EA will be equal to EB. So now I can write it this EA equal to EB. The magnitude will be same to be E. Okay, so let me remove B and A from all, and now we see the vertical components are getting subtracted while the horizontal components are getting added. So again we find the net electric field, and it will be, again we are doing the magnitude only right now, so it will be 2e cos theta, and the value of electric field will be kq upon electric field. So electric field will be 2kq, and we have the distance to be this distance we have to consider. So this distance will be, we can take we can find it through Pythagoras theorem. So we have this distance to be a and that to be y, so it will be under root a square plus y square. Okay, so it will be under root a square plus y square the whole square, so it will be a square plus y square. Now cos theta, for cos theta will be, it is base upon hypotenuse, right? So base will be a into hypotenuse is a square plus y square. Okay, now we can solve it. So it will be k q into 2a, and it will be a square plus y square power 3 by 2, and we can write kp upon a square plus y square the power 3 by 2. Okay, so again we can use that approximation that y is greater than a, so we'll have electric field at equatorial position k p upon y cube. Okay, as we'll neglect this a. Okay, so now this we know that, we can see from here that our dipole direction is negative to positive this, but we are getting the direction, equatorial direction in the opposite side, means we have calculated here, right? So this is the direction of the electric field, net electric field, so it will be in the opposite to the dipole moment. So we can say that it will be, if we have to write the direction, that will be opposite to dipole moment. Okay, and we have seen for axial it will be the magnitude was k2p, that is twice and upon x cube, and it is along the p, that is along dipole moment direction. Okay, so this is the important result, and we have to keep it in mind. So this will be very helpful in solving the numericals, and many questions are asked from this. So in this class we'll study till here, and we'll continue this topic in the next class. Till then, keep learning. Thank you.